Welcome to lecture 8, which is on the LiDAR sensors used in the drone. In this lecture, you will learn about the LiDAR sensors which are used for mapping purpose, their function and use of the LiDAR sensors and their applications in surveying and mapping field. There is a quantum jump in land surveying if we see last 50 years how this surveying technology has developed. So, we had in the electronic age the total station, then the robotic total station came, afterward the global positioning system, and then we had laser scanner. Different type of laser scanners were available which were used in surveying and mapping purpose, and then we had the drone systems which can carry all these laser based devices. So, if we talk about the LiDAR system, which is a light detection and ranging, it is basically the active sensor. In the previous lecture, we have learnt about the passive sensor. So, this is a active sensor which have their own source of energy, and they will send the energy to the object and we will record the reflected. So, they are using the lasers actually to collect the data. So, detailed measurements for maps and surveying work is carried out with the help of the laser beams. So, it records the time the laser will take to return back from the object. LiDAR technology is relatively new. It was developed in 1960s when engineers and land surveyors actually use it to produce map of the river, streams and other geographic locations. But those early days, the LiDAR technology was not used as an acronym, because merely it was a combination of the word light and radar. Back then the LiDAR sensors were very expensive and it was not possible to afford them for survey work or to in the manned aeroplanes. So, these planes could cover a lot of ground at once, but their operation was done manually and it was expensive. So, therefore, the results were not so accurate and LiDAR were not popular at that time. But with the passage of time, when the technology has improved, then it has become a very valuable tool for collecting the information about the micro topography of the ground. The greatest advantage is it can penetrate through the vegetation cover and the forest cover, and we get the information about the ground features also, which is a limitation in photogrammetry. And it is used for the 3D modeling of the terrain. This provides us higher pulse rate repetition, which increases the performance and thereby it improve efficiency, accuracy and usability of the technology. It has many uses and many applications. When we talk about the topographical mapping, it is the LiDAR technology will use to create 3D terrain models essential for construction, urban planning or flood modeling. We can use 3D model as input to that. If we are talking about the forestry and agriculture, it will measure the canopy density and biomass. So, it is helping the forest management and crop planning in the area. If we are talking about the infrastructure monitoring, it will detect the deformations and movements in the infrastructures. So, making it valuable for inspection of the facilities like dam or some mining operations. We are using laser beams. So, it is a device that will generate the light wave using only a very narrow band of the spectrum, that is called a laser in light amplification by stimulated emissions of radiation. So, a typical laser will emit the light in a very narrow with a low divergence beam with a well defined wavelength. These lasers are similar to the transistors as they generate or amplify light, just as the transistors generate and amplify the electronic signals at audio, radio or microwave frequency. In this diagram, we can see how the laser beam works on the principle that there is a transmitter in the device and that will actually transmit the laser beam. So, this is the laser beam and this is the object. It is striking to the object and returning back. So this is the reflected beam, and in the same device there is a part which is called receiver unit. Receiver unit will receive the reflected laser beam, and then the travel time will be calculated, and the distance between the instrument and the object D can be calculated with the help of the time of flight. So this is the time of flight approach, but there is another approach also which is called the phase based approach, where phase difference is measured to compute the distances. So why should we use the LiDAR system in drone? It will give us very high degree of automation. Operation is quite safe. It is less affected by atmospheric condition because the photographs and other things are affected. It is very efficient, very fast. It can penetrate through the vegetation. This is the greatest advantage of the laser which we want to use. And high post processing efficiency. Once we acquire the data, then post processing of the data is very fast. Now, if we see the LiDAR sensors, they are essential for several applications where we require very precise information, where we require very accurate coordinates. For example, the autonomous drones, you use it for surveying and mapping. So, if we are talking of the terrain mapping and 3D modeling, these LiDAR sensors are used to create very accurate 3D models of landscape or building or maybe the other structure. So this is particularly useful in industry like construction industry, mining industry or forestry. Obstacle detection and navigation LiDAR helps drone detect and avoid the obstacles which are on the way when it is moving up in the sky. So this is providing a real-time 3D map of the environment, and it allows a safe flight in a complex or dynamic environment. Then it could be the autonomous driving and delivery. LiDAR is commonly used in drone designed for delivery services of autonomous vehicle, and it ensures very precise navigation with the help of those very accurate coordinates, and useful for obstacle avoidance even in the densely populated area. So these are the greatest advantage of using the LiDAR sensor. Then there are very large number of applications. So the list here is only the exemplary list which shows that we can use in forestry planning, forest fire, river survey, oil and gas exploration, archaeological sites, then mapping glacial topography, recording of the building, mining, tunnel surveying, transmission line. So there is a long list where nowadays the LiDAR technology can be applied to collect the data and analyzing it for various purposes. Now there are obvious advantage of using the LiDAR sensor in drone because we are getting very high resolution data from the LiDAR. We get very accurate 3D maps which from any other techniques it is impossible. They are very effective in varying light conditions. So if the lighting conditions are also poor, then the LiDAR sensor is unaffected. Then precision, very high degree of precision we will get from this particular data. The LiDAR technology will also allow to operate the drone in environment where GPS signals may be unreliable. So there are areas like forested area or the urban areas where we are not getting the correct GPS signals, but the LiDAR technology is very effective in those areas. Then the drones which are carrying these LiDAR sensors, they are significantly larger in size. Typically we are actually using multi-copters, which we have learned in the previous lectures, and because of their weight of the LiDAR sensors and power they require, we require larger size of multi-copters. Now all of these high-end systems will carry out direct georeferencing of the raw data. So that is also the greatest advantage, that we are not manually doing the georeferencing of the scenes which are acquired. The final output is a large number of cloud points, and we know their three-dimensional real world coordinates. So, that is the final output which we are getting from the LiDAR, and we can use this 3D coordinates of those points to create either digital elevation model or digital surface model, which are required in many studies. So, this diagram shows that how the drone laser beams are working. You can see the large number of beams are transmitted through the sensor system, and it will scan actually a large part of the area as the drone keeps on moving. Now, the kind of data which we are getting from the LiDAR is a three-dimensional data. The horizontal or planimetry coordinates are x and y, and the height coordinates is the z, and we are getting accuracy up to 1 to 2 centimeter, which is a pretty high accuracy which we do not get from any other devices so easily. So, we can get vertical accuracy much better, but in that case the cost of the system will further increase, will go high, and the complexity of operational level will also increase as compared to the photogrammetric drone. Now, in this 3D point cloud data, the Cartesian transformation of the laser pulse data, which is the range and the reflectance image, as well as the calculated x, y and z coordinates will be done. These 3D point cloud of discrete locations are derived by superimposing the range and the reflectance image which we are getting from the LiDAR system. And these 3D point clouds are the basis of subsequent analysis, which actually we can use either in the CAD software or any GIS software. So, this is the example of the cloud point cloud data. So, you can see here that this is the raw data which has been collected for a particular area. This data is to be processed further in order to get the meaningful information from the point cloud data. In addition to this three-dimensional point cloud data, we also get reflectance image from this. So, it looks like a black and white photograph of the scanned coverage area. Individual measured points are defined as the reflectance value from this. So, highly reflective points are displayed as a light gray level pixel, and highly dark points are displayed as dark gray absorbing points, and lack of return is depicted as the black pixel from the reflectance image. So, when we look at the reflectance image, we should know how to read that reflectance state. So, this particular picture is showing this is the reflectance image, which is a black and white, and on the other side is the color coded image, which is the drone mapping which has been carried out for a part of the area. Now, the greatest ability of the LiDAR system is to penetrate through the vegetation cover. So, in this diagram you can see here that the laser beam is transmitted to the ground. So, we have reflected beam from several stages, from several heights. So, this is the first return, for example, from the top of the tree when the laser beam strikes to the ground. Then we have a second return from the branches, the tree branches which are there, we have the second return, and then we have the third return from the ground. So, we will get the three values of the elevation at that point, and the greatest advantage is that we get the elevation of the ground in the third return, which we do not get from the photogrammetric data. There are several LiDAR manufacturers all over the world. So, this is some of the list which is given over here, that the LiDAR systems is being manufactured for data collection and mapping through the drone systems. There are two components, one is the drone system, the platform, and another is the sensor system. So, this particular table shows that the LiDAR drones, different types of LiDAR drones which are commercially available, and the different type of sensors which are also commercially available. So, depending upon the use, depending upon the application, we can select the proper drone system and proper sensor systems. If we classify the LiDAR systems, basically there are three broad categories of those sensors. One is the terrestrial laser scanner, short form is TLS. Another is the mobile laser scanner, MLS, and third one is the airborne laser scanner, which is ALS. So, we will discuss these three quickly now. These are some of the available terrestrial laser scanner which are measuring the time of flight. So, they record the time, and this time is used to compute the distance between the laser scanner and the object. There are some TLS which are phase based. So, they will measure the phase difference, and using that phase difference you get the distance and the range. So, this is how TLS is being used in the field. So, all those dots on the building face are the points whose coordinates now are known to us, where the laser beam is striking to the object and recording the coordinates x, y and z coordinates using the terrestrial laser scanner. So, we are mounting this on a tripod near the object, closer to the object. As you can see in this particular picture, that the terrestrial laser scanner is mounted close to the bridge, and it is scanning the whole bridge and collecting the data, three-dimensional data, point cloud data of the entire bridge using the terrestrial laser scanner. This particular data, why I am showing you the terrestrial laser scanner, this particular data many times can be clubbed with the UAV LiDAR data in order to get enhanced information. So, there are several applications. The other application could be the slope stability in forestry area, in shipbuilding, forensic science, biometry. So, terrestrial laser scanner is not only used for mapping purpose, but you can see that there are very large number of applications where we need precision of the coordinates. We can also create from the LiDAR drone survey, we can create digital terrain model, we can create digital surface model. So, if you see this particular picture here, a digital terrain model will show the bare ground. So, the green one here is the bare ground. So, all that is the digital terrain model. So, this is all digital terrain model if I draw the surface on the ground. But digital surface model will show the highest surface including building and tree. So, the black one, black line is indicating here the digital surface model. Earlier we were working on a digital terrain model only, but with the availability of the LiDAR systems on UAV, now we have the opportunity to work on the DSM, and this DSM is quite useful once we are doing any planning on the land surface. So, this is the DEM or digital terrain model on my left and digital surface model on my right, where we can see the objects on the ground. Now, if we look at the advantages and disadvantages of the data which we are deriving from the 3D model LiDAR systems, then there are several advantages and several disadvantages also. So, advantages are more in the sense that we are getting very unique data which we do not get otherwise. We are also using different targets, and these targets are very important to us. They are set up in those areas on the ground which can be imaged, which are visible on the data, so that we know the coordinates of these target types and we can use these targets to georeference the entire data collection. So, these targets in different shape and different sizes, they are also available. We have to decide the commanding locations where these targets are fixed before we actually collect the data from the UAV. And we are using for georeferencing purpose, for registration purpose, the 3D point cloud data which is used. So, several software can be used. So, this is target based registration which is done by Cyclone software or ICP software of a building. The second category is the mobile laser scanner. So, we also collect the data once we install the entire system on a moving vehicle. So, it is a vehicular based mapping system where LiDAR, GPS and other devices, photogrammetric camera, all devices are mounted on the system. So, you can see the top roof of this particular vehicle. All the equipments are installed there, and this is a 360-degree camera. When the vehicle is moving, the laser scanner is collecting 3D point cloud data. The camera system is taking the images of the ground. The GPS will provide the navigational and the coordinates of the point. So, all the data is collected in one go while we are moving along with this system. So, this is the example how the data would look like of a street. So, on both sides of this street, of this road, you can see the housing complexes, and the data is very clear. Even one can see the shape of the window, the size of the window, and so on. This is another example of point cloud data of a hilly area. We can see the road and the surrounding feature. This is a railway line and the surrounding features on the point cloud data. So, we can collect this data in the shortest possible time with the help of the mobile system. The third category is the aerial laser scan, airborne. So, we will discuss here only the data which is collected through the UAV system or the drone system. We will not talk about the satellite laser scanner data in this lecture. So, here in the drone system, we have the laser scanner fitted, and this laser scanner will send the laser beams to the ground, and the entire area will be scanned as the drone system will move to the ground. So, how the area would look like, this is shown over here. This is the discrete points, and these are the several millions of points in the area. So, this is a piece of land where we have a river flowing through the area, and then there are some trees. So, if I further show you the processed data, so we have sandy area. The white areas are those areas which are having no vegetation cover, sand and other type of soils, and other areas which are green in color, they have the lot of vegetation cover. So, if I blow it up the area, you can see the height of the tree, you can see individual tree, you can see the river course also very clearly. So, the information is so detailed and so exhaustive that one can find out the tree density in a particular given area. So, very useful for forestry management, this kind of information. We can do flood mapping from the LiDAR data, UAV data, and also find out which are the areas where vulnerable areas. In mining activities also, we can find out what is the profile of the ground before the blast and after the blast, once we have removed the minerals from a particular area. So, you can see here that a particular piece of the ground is blast. So, this is pre-blast and this is after the blast. You have depressions, and then you can do the profiling of both the areas. So, in the second profile, this is pre-blast profile, the top one, and the bottom one is after the blast. So, one can see this particular depression. So, this depression is indicating that the minerals have been removed from this. So, one can do the calculations also, the volume of the material which has been removed. So, these are the details of the profile. So, in talking about this area where one can find out the volume of the material which has been removed. So, it improves efficiency of the work. It will save time, it improves the safety, it is the cost effective method, and it provides very accurate data on demand. Drone has also been used for forestry and its conservation when it is fitted with the LiDAR data. So, we are using for forestry and collecting lot of information below the ground and about the biomass. So, drones are equipped with different sensors, optical sensor, thermal sensor, LiDAR sensor, and flying to the area and collecting the information about the region. We can use this data for sustainable forest management, for landscape management, and for detection of the illegal activity. We can club the data from the different sources in order to derive the optimum information for these applications. We can also get the information about 3D landscape. We can create a digital elevation model of the area, or we can create a model of the tree, 3D tree. In addition, we can find out the canopy cover, how much is the area of the canopy cover, and also we can create orthophoto. So there are lot more output which we can generate once we are collecting the data from this. So we can actually do change detection or create growth model, or we can detect the tree species on the basis of the crown diameter. We can also do volume estimation, as I told you, that volume of the material which has been removed from a particular place. So with the help of the Z data, height data, we can find out the volume of the material. If we know the time T1 and time T2 elevation data, we can find out how much is the volume of the earthwork required. Then in the transportation network management, we are using the LiDAR systems, which basically continuously calculate the distance between the two vehicles and give the sort of warning if the vehicles are coming closer to each other. Then in a smart city also we have a lot of applications of it, because we have a network of the wireless sensors which will be available in the smart areas, and these sensors will provide us the data, and we will have the drone data, and we can use for applications like forest fire management. So we can use the fire management where drone is found to be very much beneficial. Drones are also used for land surveying, GIS applications in the smart cities. Here in this diagram you can see that it is providing us the maximum efficiency when we are covering a large piece of the ground through the LiDAR systems. Very high accuracy, cost optimization and deeper insights. These all are very useful for varied applications. Data processing. We are using software for processing the 3D point cloud data, and sometimes we are fusing the data from the two different sources which have been collected. In this example, the terrestrial laser scanner data was collected from the Faro scanners, terrestrial laser scanners, and the data was collected from the UAV drone system also. And Bluefire and Epix 4D, these are the software which were used to process the data, and these two data sets were merged together in order to get the final output which is shown on my right side. Now terrestrial laser scanner and drone data after fusion, how it will look like. So this is now our civil engineering department at IIT Roorkee. This is the front view of the building, and this is the top view of the building from the drone. So these two data sets are clubbed in order to enhance the amount of information. So LiDAR point cloud data will look something like this. So after processing, after cleaning, after editing the data and merging this data with the other sources, we can get something like this, a point cloud data, which in Cloud Compare software has been used for this purpose. There are very large number of LiDAR data processing software. So in this slide, and there are 4 slides actually which are indicating the kind of software which are available, and their source is also given in the last column. So this list is quite long, and these software are helpful to us to process the data. Some of these software are available as a open source software, but some are commercial software. So this is a long list, as you can see here: Global Mapper, Grass GIS and IBLAS. Then we have the LiDAR Analyst, then we have LAS tool. So likewise, this is a long list of the software and various processing of the data, various steps we can do. We can prepare orthomosaics from this, we can create digital elevation model, we can create digital surface model. Now if we compare the UAV photogrammetry data which you learnt in the previous lecture and the LiDAR data, you can see here the area covered by photogrammetry is much larger, as compared to the LiDAR data. So, that may be a sort of disadvantage, but the advantage is the error which is present or the accuracy. The LiDAR data is much more accurate than the photogrammetric data. So, advantages over the photographs could be that the dense forest and vegetation mapping, which is a problem with the photographic data, the LiDAR system can help us to map the tree canopies, and we can use this data for forestry, for conservation and for archaeological purpose. The another big advantage will be night or low light condition. The LiDAR creates an own source of energy. It is an active sensor. So, it is unaffected by poor lighting condition like cameras. So, we need good lighting condition when we are taking the photographs. So, here this particular table actually indicates the cost comparison between the photogrammetry and the LiDAR based sensor. So, as far as the accuracy is concerned, in photogrammetry we get 1 centimeter horizontal, 2 to 3 centimeter vertical over hard surface, and here we are getting 1 to 2 centimeter elevation accuracy. So, there are some merits and some demerits for each of these systems. As we see the time and efforts for each of the activity of photogrammetric drone. So, we are spending much time, 5% in flight planning, 20% time in the image acquisition, GCP measurements 15%, image triangulation 15%, DSM generation 25%, orthomosaic creation 10% of the time, and feature extraction 10% of the time. So, this is the time which is likely to be spent on each activity from right from the data acquisition to data analysis. There are several technologies, new technologies, smart technologies which are to be integrated with the drone system. So, we are collecting the data from the drone, whether we are using a photogrammetric drone or using the LiDAR drone data, but this particular data has to be integrated with the other technologies which are given over here. The other technologies are Internet of Things, for example, the blockchain technology, artificial intelligence, virtual reality, augmented reality, cloud computing, and so on. So, all these are integrated together and using some of the input from the drone data and giving us very useful results. These are some of the readings, further readings. Thank you very much.